In this lecture, we'll be talking about syllogisms. Syllogisms are two-premise arguments. So instead of the immediate inferences where we just have one premise that leads to a conclusion, these are arguments that go from two premises to a conclusion. Now we're going to be talking about standard form categorical syllogisms, and those have a particular pattern to them. They have two premises and a conclusion, and all three of those propositions are standard form categorical propositions. So they're either A, E, I, or O sentences. And there's a further restriction as well, which is that there are exactly three different terms that appear in this argument, and they appear in a very specific pattern, something that we have to memorize and think carefully about. So the major term is the first term that we want to define, and that major term is the predicate of the conclusion. Okay, so that term, and we're going to call it P because it's the major term, it's the predicate term of the conclusion, we'll call it P. That major term appears once in the first premise. Now, because that major term appears in the first premise, we also call the first premise the major premise. Now, we haven't specified where the major term appears in the first premise. It doesn't necessarily appear in the predicate place. It could also appear in the subject place. The minor term appears once in the conclusion. It's the subject term of the conclusion, so we'll call it S. And that minor term also appears in the second premise, which we therefore call the minor premise. Okay, so we've got both of the terms of the conclusion specified. The subject term S is the minor term. The predicate term P is called the major term. Each of those terms appears once in one of the premises, and then we have another term. That third term is called the middle term. It's kind of the linking term, the term that joins together the two premises, and that middle term we'll just represent with the letter M. Okay, so this is an important restriction or definition on how standard form categorical syllogisms can be constructed. And the way that Aristotle developed this kind of logic and the way that the medieval logicians elaborated on it, you can only use the techniques of this kind of logic if you have a categorical syllogism that's set up exactly this way. All right, so this is a very important definition, and you'll need to memorize it. It is something that I will test you on when we get to the second test. Now, with that in mind, we should talk about a related topic, which is called the figure of this categorical syllogism. Okay, so we've got four figures here. I'm sorry if the numbering didn't work out quite right. Let me see if I can stretch this in a way that will work. Doesn't look like it. So let me try this. This is figure 1. This is figure 2. This is figure 3. And this is figure 4. All right, so what the figures represent are the possible arrangements of the terms in a standard form categorical syllogism, given the definition that we just had. So given that the minor term is the subject of the conclusion, and we call that S, and given that the major term is the predicate term of the conclusion, we call that P, we know that the predicate term appears in the first premise, the predicate term of the conclusion, the major term appears in the first premise, and the minor term of the conclusion appears in the second premise. But notice that the P here, the major term, could appear in either the subject place or the predicate place, and that's what these four options are showing us, that the major term P could either be in the predicate place or it could be in the subject place. Same thing with the minor term S. Here's the conclusion on this last line, right? So take the subject term of the conclusion, that's the minor term, it goes in the second premise, and it could appear in the subject place or it could appear in the predicate place. Okay? So you combine those two possibilities together and you end up with four possible structures for arguments like this. We call these the figures of a standard form categorical syllogism. And what I want to show you is that there is kind of a W pattern that you can imagine here. Think of the line joining the middle terms. It kind of slopes down like that, right? and here kind of slopes like that, goes straight down there, and again like that. So when you join the middle terms together, you kind of get this W pattern, and that's how you can remember the figures. Right? In the first figure, the middle term slopes down to the right. In the second figure, they're vertically above each other. In the third figure, they're also vertically above each other. And in the fourth figure, they slope down to the left. The tricky bit is to remember this, that in the second figure and the third figure, we're talking about the middle terms sort of being jammed up against each other. So that means that in second figure, the middle terms are in the predicate place, and in the third figure, they're in the subject place. Okay, so again, the figures are something that you'll need to memorize. Sorry about the numbering here. By the way, if you go to the document in our Blackboard page that is all about categorical logic, you'll see this in detail. It's also, of course, in the textbook. Make sure you read those things and get a full understanding of what's going on here. Okay, so within these restrictions, then, there are various things that we can do. We have the figure, which we've just defined here, right, through that W diagram. We've got the four figures. We also have something that's called mood. And when we combine the figures together with the moods, we end up with the form of a categorical syllogism. So to take an example, in AAA1, that's a categorical syllogism in the first figure where all three of the sentences are A sentences. So the form there is AAA1. The figure is 1. The mood is AAA. So when we specify the mood of a categorical syllogism, we're saying which A, E, I, and O propositions appear first, second, and third in the major premise, the minor premise, and the conclusion. Now this is kind of a code, right, AAA1, and it tells you how to reconstruct an argument with that form. Here's what I have in mind. Let's say we're considering an AAA1. The way that we begin is to just write down the fact that we've got an A for each of the premises and an A for the conclusion. All right, so start with the conclusion. That's going to say all S is P. And just like just about everything we do in logic, we always start with the conclusion. Now, whatever S is, whatever term goes in the subject place of the conclusion, that's the minor term, and it will appear somewhere in the minor premise, either in the subject place or in the predicate place. And whatever term is called P, the predicate term of the conclusion, that's going to appear in the major premise, the first premise, either in the subject place or in the predicate place. The question is just to figure out where. And that's where the figure comes in, right? So we're going to be looking at a figure 1 argument, and that means we need to think about the middle terms being in the subject place in the first premise and in the predicate place in the second premise. And now we can just fill in the rest. We can say this is an all M is, and then we write the major term here because this is the major premise. In the case of the second premise, we write all S is M because S is the minor term and it appears once in the minor premise. So defining where the middle terms are tells you what figure you're in, and then which proposition types you have tells you which mood you're in. Mood plus figure gives you the form. In this case, it's an AAA1. It's not supposed to be there, just a slip of the pen. Now, it turns out that when you do all the math on this, if you combine all the different possible moods like I, O, AIO, OEA, and so on, and you think of doing one of the moods in each of the four figures, you end up with a total of 256 possible categorical syllogisms, or at least forms, right? Because you can then substitute into the place of S, P, and M pretty much anything that stands for a class of objects. But whatever your standard form categorical syllogism is, your standard form categorical syllogism, whatever that is, it's going to have one of these 256 forms. Now that seems like a lot, but the good news is that just 15 of them are valid. So the medieval logicians just memorized those 15 valid forms, and then whenever they saw a syllogism out in the world, they could decide, oh, it's one of these 15 forms, therefore it's valid. Or it's not one of my 15 forms, therefore it's invalid. Now we're not going to use that way of employing categorical logic just because it just relies on memorization, and that's not a very interesting kind of thinking. Instead, what we'll do is we'll use Venn diagrams to prove that these 15 forms are valid. We'll do that in a future lecture video. But for now, I just want to show you something about how these 15 valid forms work. Notice that the argument we just discussed was an AAA1. The medieval logicians gave that a name. Oops, sorry, Barbara. Okay, so that's the name of an AAA1. And then all of the other 15 syllogisms, the other 14 of them, also have names. And they're names that are unfamiliar to us because they're Latin names. But nevertheless, the fact that you have a name helps you to remember it. And that's how the medieval logicians did that kind of memory work. They just memorized the names. They had a little song or a poem that would help them to remember it. And they knew which name corresponded to which form. Now, as you can see here, the way I've written the word Barbara, the A, the vowels in this name tell me the mood of my syllogism. And then if you have the 15 forms valid, you know which form each name falls into. Turns out that these names are also a code in another way that I'll show you later on. All right, so if we're going to consider the 15 valid forms, we might think about this one, which is in AEA2. And in figure 2, we have our conclusion like this, so the minor term and the major term. And in figure 2, the middle terms are vertically above each other in the predicate place. Oh, I don't know what letter that is. Okay. And then the predicate term of the conclusion is the major term, so it appears in the first premise. The subject term of the conclusion is the minor term. It appears in the minor premise. And there's the form of that argument. It's an A, that's in figure 2 because the middle terms are vertically one above the other. All right, now it turns out this is a valid argument, a valid form, and we can show that by noting that this is an example of the argument that the medieval logicians called chemistries. Okay, so chemistries is an example of an AEA2, and just again to show you that that's the name of it. As we'll see, there are features of these names that again are codes that tell you how to show that the other 14 forms that are valid are all actually equivalent to Barbara, but we'll get to that later. Okay. Let's look at another example of another form. It turns out it's also valid. It's an IA in fourth figure. And to do that, again, we'd start with the conclusion. And we think about what fourth figure means. And you remember that in fourth figure, the middle term is in the predicate place of the major premise, and the middle term is in the subject place of the minor premise. And then the major term goes in the other place in the major premise, and the minor term goes in the other place that's open in the minor premise. And we have an I. Okay, so that's an IAI4. It gets the name Demaris. I'm not going to ask you to know these names, but if you happen to learn them, that's great. They're kind of fun to say. Ferio, Festino, Detizi, Ferrison, and so on. You'll see them in the document that I mentioned that summarizes categorical logic for you. What I'd like to do now, though, is to show that these 15 valid forms are in fact valid. Some of them, anyway, are valid using Venn diagrams. We won't go through all of them. That would take too much time. But the way we'll proceed is to look at a Venn diagram. And we'll see here that we've got 3 circles in our Venn diagram because we're dealing with 3 terms. So we've got an argument that has a conclusion where the subject term is called S, the predicate term is called P, and then we have a middle term. So we'll have 3 terms altogether, S, P, and M. And because there are just 3 terms, each term gets its own circle, we can arrange our Venn diagram like this. So if you just look at S and P, that's the standard way that we've set up a Venn diagram when we're dealing with the immediate inferences, for example. And all we've done is now superimpose on top of that a 3rd circle, the M circle. And we'll see how when we fill in this Venn diagram, we only ever need to think about 2 circles at once. In fact, you need to ignore the 3rd circle while you're working on the other 2. Now, let's do a Barbara. So we're going to be in first figure with the middle term sloping down to the right. And that means this is the sketch of our argument, and we're dealing with A in each of our sentences. So we have all M is P, all S is M, therefore all S is P. Now, a fun exercise is to try to substitute in for M, P, and S with terms that make these sentences true. That's a fun thing to try to do. So perhaps you could say something like, all mammals are air breathers, all beavers are mammals, and then you would conclude, therefore, all beavers are air breathers. Something like that. Okay. Now, generally speaking, I'm not going to bother to write this out when I have this, right? Because this tells me the very same information. It tells me I'm dealing with an A proposition, and it tells me in what order the terms appear. So really, this is all we need to do a Venn diagram. But if you want to do this, if it helps you to think about it better, then go ahead and do that. All right, so how do we do one of these Venn diagrams when we're dealing with 3 circles? It looks a bit intimidating, but it's really the same as we've been working with. Now you remember that when we've got a Venn diagram of an A proposition, we have to shade in the region of the subject class that's outside the predicate class to show that that region is empty. So that's what we'll be doing in each of these cases. All right, so let's take the first premise, the A proposition, and we'll shade in the region of M that is outside of P. So we're dealing with the M circle and the P circle, and we're totally ignoring S at this point because S doesn't appear in the first premise. We're just trying to diagram that first premise. So we need to think about the region of M that's outside P. That's that area there. Never mind the little extra I gave you there. And then we shade that in to show that that region is empty. Now it's a very good idea when you're drawing these by hand to do what I did here and have your shading lines point towards the other circle that you're working with. That way it's much easier to go back and correct your or check your work. You can then see that in this case this shading refers to M and P, and that tells you you're dealing with the major premise, so you can double check that you've got it correct later. If you want to, you can also use separate colors. I'll do that here because it makes things just a little bit easier to see what's going on. Now the second or minor premise says all S is M. So now we're dealing with the S circle and the M circle. It's an A sentence, so it's telling us that the part of the subject class that's outside the predicate class is empty. So we can shade that area in. Now notice that I'm totally ignoring the P circle. It's not part of what I'm doing when I'm diagramming the minor premise. P doesn't appear in the second premise, so it's of no concern to us. All right, so next we have to think about the conclusion. And the conclusion is going to involve the S circle and the P circle. Now, that's an A proposition, all S is P. And if we were to diagram that, we'd be looking at the region of S that is outside of P. I'm going to shade it right in just to show you exactly what we're talking about here. Notice that that area was already colored in before we even thought about the conclusion, right? So this part, and I'm going to give a different color here to make this a little bit more clear. maybe this one. Notice that this part of the diagram is shaded in because of what we did between the S and the M circles. In other words, because of the minor premise. And the little corner right here, this little triangle, that's shaded in already because of information that we got from the major premise, so between M and P. So in the end, this whole region is already shaded in once we've diagrammed the premises. That means that once we've got a diagram of the premises, that's a proof that this has to be true. In other words, this diagram that shows that this region of S that's outside of P, that has to be empty. That's guaranteed to be true whenever the two premises taken together are true also. So that's how we do a proof with a Venn diagram. And again, it's just focusing on two circles at a time. It's a little bit intimidating, but it's not that hard. It's the same as what we've been doing before. What I need you to do is a bunch of practice with Venn diagrams. So look at the Venn diagrams, look at the examples in the textbook and do a bunch of them. Some of them will be assigned for homework, but you should do all of them. And you can also look at the list of the 15 valid forms and give yourself as much practice proving those to be valid as you need. Okay, so let's look at one more just so we have some more practice with this. Let's do a detesi. A detesi is an I, and that's in third figure. In third figure, you look up at that diagram, and you'll see that the middle terms are vertical in the subject place. And then according to the other rules for standard form categorical syllogisms, that's how we fill in the code for a detesi. Now again, this is one of the 15 valid forms, so we should find that it's valid as we do this. Let's start with the universal premise, the A sentence, and then later we'll do the particular premise, the I sentence. This is really the only restriction that you have when you're trying to do the Venn diagram for a syllogism. If you have a particular and a universal sentence, always diagram the universal sentence first. I'll show you later why that's the case. But for now, let's just do that. So we've got M, we've got P, and the region of M that's outside of P needs to be shaded in. Okay, so there's our A proposition done. Now the I proposition says some M is S. We're dealing with the M circle and the S circle. In other words, that I proposition is telling us that this intersection of S and M has to be non-empty. Well, how do we show that something's non-empty? We draw an X. But where do we put it? On which side of the line for P should we put this X? Well, in this case, because we diagrammed the universal proposition first, we know that this region has to be empty. So there can't be an X in there, or that would make that false. That would make the A sentence false. So because we're taking the premises as true, we have to leave that region empty. That means that the way to make the second premise true at the same time the first premise is true is to put the X right there. Okay? Now we check the conclusion, which says that some S is P. That's the claim that this intersection is non-empty. Now if you ignore the M circle and you saw an X in there, you would say, oh, okay, good, we've already got it. But do we really have it in this case? Because actually there is an M circle. And this X is saying that there is a thing that is S, P, and M. It's in the intersection of all three regions, which we could call SPM. And what we've just shown from those premises is that that region is non-empty. But it could have been that we had an object in that region, which is this one right here, and we don't know which is correct. Turns out that as long as there is something in any part of that SPM, whether it's in, as long as there's something in SP, right, that's what that conclusion says. It doesn't matter whether it's in M or outside of M. Let me draw that a little bit more clearly. oops. So this region here is SP, right? And there are two ways that you could have SP. You could have SP and M, or you could have SP with non-M. Now this conclusion, the I sentence, sum S is P, only specifies that this is true. It doesn't tell us that it's got to be this way or that way. It could be either one. So as long as one of those has an object in it, then that tells us that this is true. Okay, so that's what we have here. We have an X, it happens to be in the SPM intersection, but that's enough. It guarantees that that conclusion is true. The upshot here is that once we've diagrammed the A and the I premise, if those sentences are true, that guarantees that conclusion to be true. Whenever the premises are true, the conclusion has to be true. So again, this is a valid inference, and our Venn diagram shows us that. Now, I mentioned a rule a minute ago, which was that we should always diagram universal propositions first. And I want to show you what happens if we don't do that. Let's say we did our particular proposition, the I proposition, first. That says sum M is S. So we're dealing with the M circle and the S circle, and we're saying that there's something in this intersection, right? And the way we represent that is by putting an X somewhere. Now, if we don't know where to put it, either on the P side or the non-P side, the way to do it is to draw the X directly on the line. Okay, we don't want to assume something that we don't know. All we know is that the intersection of S and M is non-empty. We don't know whether that means that there is a P or that there is a non-P. So we can't assume one way or the other with regard to P and non-P. To avoid that, we put the X right on the line. But now, when we diagram the universal premise, when we're dealing with all M is P, we will have to say that the whole of this region out here is shaded in. That means that this X can't be in this region over here, it has to be in the other area. So shading it in essentially bumps it off the line and tells us it has to be in the intersection SPM. All right, so you could do that and then just bump the X off the line, but that's an extra step. So to avoid that extra step, just diagram your universal premises first before you do your particular premise. Otherwise, there's no real tricks here. All right, so we'll do one more example and then we'll end this video. Let's do a Ferio. That's an E, I, O in first figure. First figure has the middle term in the subject place in the major premise, and it has the middle term in the predicate place in the minor premise. So there's our sketch of an EIO. Notice we have a universal and a particular. We're going to diagram our universal sentence first. That says no M is P. So looking just at the M and the P circles, we shade in this region that is the intersection MP. Okay, there's nothing in there. Now for the I sentence, sum S is M, dealing with the S circle and the M circle, and the intersection between them has to be non-empty, even though this region, the SPM region, is empty. That means that the X goes right there. Now the conclusion says sum S is not P. All right, what would that look like if we were just doing a diagram of sum S is not P? Well, if we had S, P, right, we'd have something out here. There'd be an X in the region of S that's outside of P. So, do we have that in this situation? Well, yes, we do. We just saw that there's an X right here, and that is an X that is in the region of S that is outside of P. So we have indeed got the result that we need to say that this conclusion is true whenever these premises are true. Now, an X over here would also have made the conclusion true. That happens not to be the case in this instance. That's not what we've got. But nevertheless, this is a case, an example of an S that's not P. And so the fact that there is an X here is enough to make the O conclusion true. So whenever these premises are true, that guarantees that this conclusion is also true. It might be useful for us to examine a case of a Venn diagram that shows us an invalid categorical syllogism. So let's try one of those. All right, so I'm going to pick something that's not in the list and therefore of 15 valid forms and therefore it doesn't have a name. I'll do an OAO in figure 2. All right, so we have a universal premise. We should do that one first, and a particular premise here. The universal premise says all S is M. In other words, the region of S that's outside of M is empty. All right, and then the particular premise, sum P is not M. Dealing with the P circle and the M circle, we're saying that there's some P that's not M. That means that there is something over here. Now it could have been in this region, but since that region is empty, it bumps off the line and goes over here. Now the conclusion says some S is not P. All right, so now we're dealing with the S circle and the P circle, and to have some S be not P would be to have an X in the region of S that's outside of P. And that's not what we have. To put that information into the diagram, you have to put an X there. In other words, you have to change the diagram to represent the conclusion. And in a Venn diagram, whenever you have to change the diagram to represent the conclusion, that means that the argument is invalid. Okay, so we'll use this technique in the homework and in various other places, including the test. It's important that you get enough practice to be good at this and to be able to do it quickly enough in a testing situation. And you can give yourself as much practice as you need to get comfortable. You can just make up a mood and figure and then do the diagram of that argument. And then you can check your work by looking at the list of 15 valid forms. And if you find that an argument is valid, it better be on that list of 15. And if you find that an argument is not valid, then it is not supposed to be on that list, right? So if you find it in the list and you said the argument was invalid, that means you made a mistake. All right. Let me know if you have any questions about this. This is important. It's the kind of thing that you can only really fully understand if you do enough work on it. So spend the time. You're going to need more than one day. Spend some time on it over a week and make sure that you've got enough practice to really master it. Let me know if you have any questions.